All right, now the female reproductive system. This functions to produce gametes and reproductive hormones just like the male system, but it also has the additional task of supporting the developing fetus and delivering it to the outside world. Just like the testes in males, the ovaries are going to be the female gonads. The gamete that they produce is called an oocyte. The uterine tubes receive the oocyte after ovulation, and fertilization will occur there. The uterus is where the embryo is going to implant and grow and be supported. It's about the size of an upside down pear and is tightly tucked into the pelvis. The muscular layer of the uterus contracts during menstruation and labor/delivery in childbirth. So looking at the ovaries, this is that upside down pear looking of the uterus here. The ovaries are those female gonads and are paired ovals about the size of an almond. Oocytes develop within the outer layer of the cortex, each surrounded by supporting cells, and those two together make up what is known as a follicle. The process of developing oocytes is called oogenesis, and ovulation is the release of the mature oocyte from the ovary into the uterine tubes. So now looking at gametogenesis and oogenesis, it's so gametogenesis is the formation of gametes. So in men, it'd be spermatogenesis, and in females, it's oogenesis. The process begins in females in the ovary with the ovarian stem cells. These are called oogonia, or oogonium for single. Oogonia are formed during fetal development, and they divide via mitosis, much like spermatogonia in the testes. Unlike spermatogonia, however, oogonia form primary oocytes in the fetal ovary prior to birth. These primary oocytes are then arrested in this stage of meiosis. So you'll see here, before birth, they're already arrested. They don't even finish meiosis. Meiosis 1, that is. This resumes once puberty hits. Meiosis 1 resumes. And then it can divide into a secondary oocyte and form the first polar body, which we'll get to here shortly. But then it arrests again in meiosis 2 here. The number of primary oocytes present in the ovaries declines from 1 to 2 million in an infant and approximately 400,000 by puberty, but then to just be 0 by the end of menopause. And menopause is the cessation of a woman's reproductive functions because they are born with limited eggs or oocytes in their ovaries from the start. The initiation of ovulation, or the release of an oocyte from the ovary, marks the transition from puberty into reproductive maturity for women. From then on, throughout a woman's reproductive years, ovulation occurs approximately once every 28 days. Just prior to ovulation, a surge of luteinizing hormone, or LH, triggers the resumption of meiosis in a primary oocyte. And that's what you see here. The LH will trigger the resumption of the primary oocyte into a secondary oocyte. However, as you can see here, this cell division is not equal. It does not contribute to 2 equal cells. One is bigger than the other one. Instead, the cytoplasm is divided unequally, and one daughter cell is much larger than the other. This cell is called the secondary oocyte, and it eventually leaves the ovary during ovulation. The smaller cell, called the first polar body, may or may not complete meiosis and produce secondary or second polar bodies. In either case, it just disintegrates. Therefore, even though oogenesis produces up to 4 daughter cells, only 1 survives. The rest are unequally divided. Meiosis, again, of that secondary oocyte is only completed, meiosis 2 that is, once fertilization occurs, once a sperm penetrates. Meiosis 2 then resumes, producing 1 haploid ovum that at the instant of fertilization by a haploid sperm becomes the first diploid cell of the new offspring, a zygote. So what you're seeing here, and you'll see questions on this, is 2 meiosis arrests during oogenesis. They arrest before birth in meiosis 1, and then it resumes after after puberty up until meiosis 2, but then it does not complete meiosis 2 until fertilization occurs. So the process of maturation of ovarian follicles is called folliculogenesis. This is literally the formation of a mature follicle, which is the oocyte and its supporting tissues. And this leads to ovulation of one follicle every 28 days. The primordial follicle is in a resting state and goes through changes in the ovary until it reaches the tertiary follicle stage, where it then expels its secondary oocyte and surrounding granulosa cells from the follicle and out of the ovary. And so you'll see this is our ovary and we expelled it out. Most follicles won't even make it to this point, and in fact 99% of follicles are going to degrade in the ovary while the remaining 1% actually get ovulated. You might be asking, well, what happens to the rest of the cell structure if it just spits the secondary oocyte and some of the supporting tissue cells out and the rest remains in the ovary? That remaining aspect of the follicle does not just degrade, it actually turns into a functioning endocrine gland called the corpus luteum. This corpus luteum is the remaining follicle after ovulation. And again, it's glandular, which means it's secreting a hormone which is going to affect the female reproductive system. It's going to release progesterone. This hormone is going to be affecting the establishment and the maintenance of pregnancy in the female. It also prepares the mammary glands for lactation, for when a baby is actually conceived. The corpus luteum will degrade if pregnancy does not occur after about 10 days, but if it does occur, it will remain for 3 months to help support that pregnancy with progesterone.